Okay, in this video we're doing the probably the hardest way possible to solve a system by hand, right? But it's a lot of thinking and it's a lot of step by step, and it's a lot of good things. Okay, so let's talk about the basics here, the reason behind being able to do this. Okay, so what we're going to have is we're going to have three matrices. One matrix is going to be called your coefficient matrix, which is made up of the coefficients of your variables. This we'll call A. And we're going to multiply that by your variable matrix. In this case, there's two of them, X and Y. And that's going to equal some third matrix B. Okay, so this is our general statement. This is how we're going to do it. You're going to take your linear equation here, or your system, and we're going to write it as a matrix system. So let's see how we do that. Let's come over here. So these are your coefficients. Notice that your x's are lined up in a column and your y's are also lined up in a column. Okay, so in case your equation is not in that format, you need to put your equation into that format first. Okay, so now we just take the coefficients. We have a coefficient of 1 for x and 2 for y, 2 for x and minus 5 for y. And that becomes your coefficient matrix, what we're calling A. Okay, and then we're going to multiply that by your variable matrix. So we have two variables. They are x and y. Okay, the first variable goes on top and the second variable goes on bottom in your 2 by 1 matrix. Okay, and then that equals your solutions matrix over here, 1 and negative 16. So our first job is to take your system of equations and write them as a matrix. Okay, write them as a matrix. So now that we have that, let's talk about what we do with that. So let's come over here. If we're going to solve this matrix equation, right, I want to get x by itself, which means somehow I need to move my A matrix over to this side. Okay, and we don't divide a matrix by a matrix. Okay, matrix division is not a thing. So the other way that we need to get A away, or rather to have A basically disappear, is if you multiply it by its inverse, right? Because if you multiply by its inverse, then in essence it becomes a 1, and 1 times anything is that anything. So what we're going to do is we're going to left multiply by A inverse. Okay, and multiplication matters what way you do it in a matrix. Okay, so it matters what side you multiply on. So we're going to multiply both sides, left multiply by inverse. And this is, of course, B. Okay, now what happens with A inverse and A, right, this becomes the identity, and in essence, it is gone from your equation. So that's the reason why we want to find the inverse, so we can multiply by it to move your matrix A from the left side of your equation, where x is, to the right side, where we have all of our numbers. Okay, so that's the theory behind this. That's why we want to first figure out what the inverse matrix is. Okay, so that's our next job, is to find out what the inverse matrix is. Okay, and we're looking at your coefficient matrix. This is what we're going to find the inverse of. So if you remember from yesterday, you find the inverse matrix by first finding the determinant. So we need to find the determinant of our coefficient matrix, 1, 2, 2, minus 5. And we do that by doing the diagonal product. So that's 1 times negative 5 minus 2 times 2. So the determinant here is negative 5 minus 4, which is negative 9. Okay, negative 9 is the first part of your inverse matrix, is by finding that determinant. Okay, so then the inverse matrix is found by doing 1 over the determinant times, right? There's a formula for a 2 by 2 matrix. So we're going to switch these two positions. This is what the formula says, and then make these ones negative. Okay, there's a poster in class, of course, that tells you all this stuff, but that's the formula that we're going to use to find the inverse. So this is a -5 and a +1, and then both of these 2's become negative. And when I multiply all of these terms by -1/9, okay, because that's our last step, I get a 5 over 9 in this position, and then a 2 over 9, and then another 2/9, and then a -1/9. Okay, and I found that by multiplying all 4 of these terms of your matrix by this -1/9. Now that we've found our inverse matrix, let's solve for your variable. So we have the xy, that's your variable matrix, equals our inverse, right? We multiply on the left, so 5/9, 2/9, 2/9, and -1/9. That's your inverse matrix, and we multiply that by 1 and -16, which was your solutions matrix from up there, right? 1 and 16. So this is our setup. Now we are primed to solve for x and for y. Okay, once we get to here, remember this is your variable matrix. This is your inverse of your coefficient matrix, and this is your solutions matrix. So first we solve for x using matrix multiplication. So we're going to take this row, this top row, and multiply it by this column, because that's how matrices are multiplied. The row of the left matrix times the column of the right matrix. And it's the first term times the first term, so -5/9 times 1. I need to make it bigger. X equals 5/9 times 1 plus, right, we're doing this row times this column. 5/9 times 1 plus 2/9 times -16, right? This is the procedure for matrix multiplication, in case you've never done it before or has been a while. You do the first term of your row times the first term of your column plus the second term of your row times the second term of your column. And if we had more terms, it would have been the third term of your row times the third term of your column. It's row times column, position by position multiplication. That's how you multiply matrices. So 5/9 times 1, well, that's just 5/9, minus 2 times -16 is 32/9. Okay, because when you do a fraction times a whole number, it's top times top, and 16 over 1, bottom times bottom. So what is 5/9 minus 32/9? 5 minus 32 is -27 over 9, which, believe it or not, is actually -3. And you thought we were going to get some crazy dumb fraction with a 9 in the bottom. Nope. It divides out to be a nice number. X equals -3. And we're going to do the same procedure to figure out what our y value is. Okay, so that's going to use this row, right? Y is the bottom row, this row times this column. First position times first position. So y equals 2/9 times 1 plus -1/9 times -16. Okay, second term times second term, first term times first term. Okay, this is how we do matrix multiplication. So this is 2/9. 2/9 times 1 is 2/9. And then we have a positive 16/9. -1 times -16 is positive 16. 2/9 plus 16/9 is 18 over 9, which divides to give you 2. Okay, so yes, all this work, look at all that work to get the answer negative 3, 2. So using the inverse, yes, it does. It takes a while, and you would probably never want to do this by hand if you could help it, because there are much faster and easier ways to solve a system, like substitution and or elimination. Okay, but this is a way to do it using a matrix, which might come in handy some days. Who knows? Probably no, will never for your life, but there we go. Okay, let's look at another example. Let's do it. Here is your matrix, or here's your system, right? This is a system of equations. We're going to solve it by creating a matrix. So we start with our coefficient matrix. So we have an 8x, we have a 5y, we have a 5x, and we have a 3y. Right? Times your x and your y, your variable matrix, is equal to your solutions matrix, negative 6 and 2. Next, we find your inverse. So part of finding the inverse is the determinant of this coefficient matrix. Okay, and that's done by doing 8 times 3 minus 5 times 5, which is negative 1. So we have a determinant of negative 1. Okay, so then A inverse is 1 over negative 1 times, let's switch your 8 and your 3 and make your other diagonals negative. But now we're just going to make all of them the opposite sign because we're multiplying everything by negative 1. So your inverse matrix is negative 3, positive 5, and negative 8. So that is your inverse matrix. So we take that inverse and we write it as a matrix solution. So our variable matrix, all right, equals the inverse that we just calculated, negative 3, 5, 5 minus 8, times your negative 6 and 2, right? That was your solutions matrix. So now we got to do our matrix multiplication. So x is this row times this column. Negative 3 times negative 6 plus 5 times 2. Okay, first position negative 3 times first position negative 6 plus second position 5 times second position 2 is positive 18 plus 10, which is 28. And now we find y. So we use the bottom row times this same column. So y equals 5 times negative 6. First position on the bottom times the first position of your row plus negative 8 times 2. Second position times second position. We're always adding them together. Negative 30 plus negative 16 is negative 46. So the solution to this equation is an x value of 28 and a y value of negative 46. Okay, so no, it's not the most efficient. It's not the most time intensive, but it is one way to solve this using a matrix without using a calculator. So let me pause for a second and give you the answers to your assignments, because then I'm going to grade all of your work. Okay, so when you're working on your assignments by yourself or with your friend, these are the answers that you should be looking for. If you get these answers, then you know you have done your questions correct. Okay, so this is solving a system using an inverse matrix, right? Not the most fun, but it's a pretty good way to do it. Okay, bye.